let's get started. So we have, consider the function f of x, for x is greater than or equal to 0. So it exists at 0, and x does not equal 4. I'm going to sketch it so I can talk about it up here. So it's sort of like this, then it comes down, touches, there's an asymptote, and then there's this thing happening here. Alright, so that's at x is 5, this is at x is 4, point C is at x is 3, point of inflection at x is 2, and then a local max at x is 1, A, B, C. Very good. Points A and C are the function's only stationary points. So it's stationary at A and it's stationary at C. The slope is horizontal there. They've got their x coordinates. Point B is the function's only point of inflection. So that's the only point of inflection with an x coordinate of x equals 2. And the function also has a vertical asymptote at x is 4. You can see it. Part A, complete the sign diagram for the first derivative. Okay, so the first derivative tells us where's it increasing, where's it decreasing. So if you're walking along it, you can see it's increasing until we get to A. So we have positive slope, and I should use the x values we're given, sorry, not the coordinates of those points. So it's increasing until we get to A. Then it's going to be decreasing until we get to point C. So it has negative slope, you'd be walking downhill. And then it has positive slope, all right, after that, but it doesn't exist at 4, okay? The function does not have slope at x is 4, it's undefined, so there's an asymptote there. And then after x is 4, it still has positive slope. So that's what the sign diagram is going to look like. You're just asking yourself, when I'm walking along, am I walking up or am I walking down? Okay, 2 marks there. Let's go for the second derivative. So the second derivative is a statement about when is it concave up and when is it concave down. And what we can see is concave down until we get to B. That's the point of inflection, right? So concave down, that means it's negative. The second derivative is negative until we get to 2. And then it's concave up right up until the asymptote at 4. Okay, it's concave up over that interval. And then after the asymptote, it's concave down. So negative. Okay. Then part B, sketch a possible graph of the derivative function. 5. And so what we're going to do, we're going to refer to this sign diagram. That's going to tell us when it's above and when it's below the axes here. So it's positive, and then it's negative until we get to here, and then there's the asymptote at 4, and then it's positive again as well. The other thing to point out is, remember, points of inflection on the original function correspond with turning points on the derivative function. So that means we're going to have a turning point at x is 2. So we're above until we get to 1. So it's going to start here somewhere, we don't know, we're not given any values on the y-axis. And then it transitions to below. We have our turning point here at x, x is 1, x is 2. So we're above, we're below until we get to 3, and then we're back above. And so it's going to do something like that with this asymptote here. And then we're above, all right, and I'm going to describe why it's taking this shape. All right, I might exaggerate it here a bit more to talk about it. All right, but it's going to have a shape like this. And these first 2 marks are quite easy to get. This third mark is quite tricky. So I might just explain the first 2 again. We can see from our sign diagram, we're above until 1, then we're below between 1 and 3, and then we're above again until we get to the asymptote. And we've got the local minimum at B. Points of inflection on the main function correspond with turning points on the derivative function. Okay, let's talk about this part to the right of the asymptote. What's going on there? Well, this is the slope function, all right? And it's telling you about the slope. Now notice, the closer and closer and closer we get to this asymptote, the steeper and steeper and steeper the line gets. So what that means is the slope is more and more positive the closer you get to x is 4. And so if the slope is more and more positive the closer you get to x is 4, that means it's sort of way up here, the closer it is to the asymptote. And as you move along, as x increases after 4, the slope decreases. So the slope function, it's coming down, right? It's not negative, it's still increasing, but the rate at which it increases is decreasing. It's slowly plateauing off. So that's why it has that shape. So I expect you to get those 2 marks. That third one's a little bit tricky to see. Okay, any questions? All right, let's move on to 5 then. We have the function